Hi, and welcome to What's New in Core Data. My name is David Stites, and I'm an engineer on the Core Data team. In this session, you'll learn about new technologies in Core Data that will help you more quickly and easily design, query, update, and migrate the Core Data data model in your app. I'll start by talking about composite attributes, a great new way to organize structured data in your app's model, before talking about how to stage your most complex model migrations so that you can use lightweight migration. And I'll finish up with how to defer your model migrations to keep your app responsive. Composite attributes are a new type of attribute. Composite attributes allow for the encapsulation of complex and custom data types within a single attribute. Each composite attribute is composed of attributes of the built-in core data types that you're already familiar with, such as string, float, int, and data. Composite attributes may be nested within each other so that a top-level composite attribute may contain additional composite attributes. The Xcode Core Data Model Editor has been updated to make it easy to define and manage your model's composite attributes. Composite attributes are a compelling alternative to using transformable type attributes to create durable, custom data types. There is no need to write code that transforms the attribute's value. Unlike transformable attributes, composite attributes allow NS fetch requests with NS predicates configured with the composite attributes namespaced key paths. Composite attributes can be used to encapsulate a proliferation of flattened attributes, leading to more maintainable and readable code. Composite attributes can be used to improve the performance of your app. If your data model is composed in such a way that fetching one entity almost always results in accessing a relationship to another entity, you can refactor that relationship into using composite attributes. The effect of embedding a composite attribute in the first entity is that it prevents faulting in objects across the relationship. The composite attribute class is NS Composite Attribute Description. The attribute type for an NS Composite Attribute Description is NS Composite Attribute Type. The NS Composite Attribute Description class contains an array, elements, that consists of NS attribute descriptions or other nested composite attribute descriptions. The elements array cannot contain other types of property descriptions, such as NS relationship description. Attempting to set invalid elements will result in an NS invalid argument exception. I'm going to describe to you how to adopt composite attributes with a demo. Consider this basic data model with an aircraft entity. It has a number of attributes, including a colors attribute, which is a transformable type. The transformer for that type stores and parses a formatted string that describes the primary, secondary, and tertiary colors of the aircraft. I'll improve this entity by replacing the colors attribute with a composite attribute color scheme to store the paint colors of the aircraft. Color scheme is a composite attribute with the elements primary, secondary, and tertiary, each of which are a string attribute. In Xcode, I'll open a project which is an app I use to track my flight time. The data model for that app is configured with the aircraft entity that I just talked about, as well as a couple other entities. To begin the conversion in the Core Data Model Editor, I'm adding a new composite attribute named Color Scheme. Within that composite, I'm adding 3 string attributes: primary, secondary, and tertiary. In the aircraft entity, I'll add the composite attribute and set the type of that attribute to color scheme. The work in the model is now complete, and it's time to update the code. In my aircraft implementation, I'm adding a new property, NSManage var color scheme, whose type is a dictionary with a string key and any object. As I use this composite attribute throughout the code, I'm accessing the values using dictionary notation, with the attribute's name as the key. Here I'm setting the color scheme attribute of the aircraft by using the string keys primary, secondary, and tertiary. Similarly, when I configure an NSFetch request with an NS predicate, the elements of a composite attribute are accessed via namespace key path. Here, colorscheme.primary is used to filter on that attribute. As an application evolves, it may become necessary to change the data model. Updating the data model requires that those changes are materialized in the underlying storage schema. If a num_passengers attribute is added to the model, the corresponding storage must be updated. The process of performing schema changes is called migration. After migration, the changes are fully reflected in the underlying storage. Core Data has a built-in migration toolset to help keep an app's data storage up to date with the current data model. Collectively, these tools are referred to as lightweight migration. To learn more about lightweight migration, watch Evolve Your App Schema from WWDC 2022. Sometimes, the combined changes to a data model exceed the capabilities of lightweight migration. The solution to this problem is a staged migration. The Staged Migrations API was designed with a couple goals in mind: help you migrate complex data models that have non-conforming lightweight schema changes, simplify your app by potentially removing thousands of lines of code related to migrations and the migration infrastructure, and provide opportunities for your app to gain execution control during the migration process to perform various tasks. To use this API, there are several steps you'll need to take. Determine when changes to your model do not conform to operations supported by lightweight migration. Decompose non-conforming model changes into a series of conforming model changes that are supported by lightweight migration. Describe a total ordering of NSManage object models to core data using the new Staged Migrations APIs. And have core data execute an event loop that iteratively steps through each unprocessed model in a serial order and migrate the store. At certain points during the migration, execution control will be given to your app to perform any necessary tasks related to that migration. To determine when your model has non-conforming lightweight changes, you have several options. The first option is to review the schema changes manually and ensure each change is eligible for lightweight migration. The second option is to try to open the persistent store with the new model and the lightweight migration options NS Migrate Persistent Stores Automatically option and NS Infer Mapping Model Automatically option set to true. If the changes are not lightweight eligible, you'll receive an NS Persistent Store Incompatible Version hash error. The final option is to use NS Mapping Model .inferred mapping model, for-source model, destination model. This method returns the inferred model if core data was able to create it, otherwise it returns nil. Considering the aircraft model again, it has a new attribute, flight data, that stores data in a binary format. Suppose there's a need to denormalize this model and separate all flight data into its own entity type, all while preserving any existing data and the relationship to the aircraft from which it was generated. This is a very complex model change and is not eligible for lightweight migration by itself. These changes need to be decomposed to use staged migration. When decomposing non-lightweight changes, the goal is to transform migration tasks that aren't eligible for lightweight migration into a minimum series of migrations that are eligible for lightweight migration. Each of the models introduced will have one or more operations that is within the capabilities of lightweight migration that compose the non-conforming changes. The result is a series of migrations where each model is lightweight migratable but equivalent to the non-conforming migration. Returning to the example, I've labeled the original model Model V1. This model migration will be decomposed by introducing two new model versions, Model V2 and Model V3. In Model V2, the aircraft entity gains a relationship called flight parameters, which is a collection of newly created flight data entities. The flight data entity has a binary type attribute data and a relationship to an aircraft. To preserve the existing data, the migration stage will copy the data from the aircraft entity over into the new flight data entities and relate them to the aircraft. Our final model is Model V3, created from Model V2. In Model V3, the old flight data attribute is deleted from the aircraft entity, and the model is successfully denormalized, and all existing data is preserved. Each of the steps described is within the capabilities of lightweight migration. To describe a total ordering of models, the Core Data Framework level support consists of the following classes: NS Staged Migration Manager, NS Custom Migration Stage, NS Lightweight Migration Stage, and NS Manage Object Model Reference. The NS Staged Migration Manager class encapsulates a total ordering of NS Custom Migration Stages and the supplementary NS Lightweight Migration Stages that is described by you. The Staged Migration Manager also manages the migration event loop and provides access to the migrating store via an NS persistent container. The manager is added to the store options using the key NS persistent store Staged Migration Manager option key. Migration stages form the basis for migrating between versions of a model. As you adopt stage migration, you'll describe each model version to Core Data using either an NS Custom Migration Stage or an NS Lightweight Migration Stage. The NS Lightweight Migration Stage class describes a series of models that did not require decomposition and that were lightweight migration eligible. This will likely be the majority of your models. These lightweight migration stages are used to supplement the total ordering of models described to Core Data. All lightweight model versions must be represented in one or more NS Lightweight Migration Stages. Each decomposed version of your model you create will be represented using an NS Custom Migration Stage and contain a source model reference and a destination model reference. NS Custom Migration Stage provides optional handlers that run immediately prior to and after the migration stage. These handlers give you the ability to run custom code during the migration process. Stage migrations make use of the NS Manage Object Model Reference class. This class represents a promise of an NS Manage Object Model. During migration, Core Data will fulfill this promise. An NS Manage Object Model Reference is flexible and can be created in a number of different ways. Every NSManage object model reference needs to be initialized with a version checksum. This is to validate the model hasn't inadvertently changed. The checksum can be obtained using the NSManage object model version checksum method. Alternatively, you can retrieve the version checksum from the Xcode build log under Compile Data Model. Search for the string version checksum. For version models, the checksum is also available in the versioninfo.plist of the NSManage object model bundle. Returning to the example, to start using stage migration, I'll begin by creating model references for each of the three models. I'm using the initializer that accepts a model name and bundle reference, but there are other options as well. The next step is to describe the required migration stages. Since the first stage only added the flight data attribute, that can be represented in a lightweight stage, as adding attributes is a lightweight change. The next stage, however, will be a custom stage, because the model changes were decomposed into two model versions, and we need to run custom code to preserve existing data. The custom migration stage is initialized with model v2 and model v3. In the will_migrate handler, the code fetches entity rows where flight data is not nil. The generic NSManage object and NSFetchRequestResult types are being used instead of the aircraft_manage object subclass due to the fact that it's possible that the aircraft class may not exist as expected during the migration. For each fetched aircraft entity, the data is copied into a new instance of flight data, and the two entities are related and persisted. At the end of the execution of this migration stage, the store schema is updated to the latest model and the existing data has been preserved. To finish the stage migration, I created an NS-staged migration manager with the lightweight migration stage and the custom migration stage. The NS-staged migration manager is added to the NS-persistent store description options with the key NS-persistent store stage migration manager option key. The persistent stores are then loaded to start the migration process and affect the store schema. And that's it. Core Data will automatically apply the required stages and migrate the store schema. Some lightweight migrations require additional runtime that your app may not be able to provide in the foreground. The process of transforming user data during lightweight migration is not instantaneous. For example, if the migration involves copying data from one column to another or one table to another, it may take some time. This can result in a frustrating user experience, especially if the migration is done at launch time. Deferred migration can help you solve this problem. This API will allow you to defer some of the work done during lightweight migration with the ability to finish the deferred work at a later date. During a lightweight migration, if an entity has a migration transformation that requires cleanup, such as updating indices or dropping a column after performing a table copy, this table transformation can be delayed until you deem that the resources are available to perform the table transformation. The lightweight migration is still synchronous and occurs normally. Only the cleanup of the schema is deferred. Your app will use the latest schema as normal. To opt into deferred migration, set the NS Persistent Store Deferred Lightweight Migration option key in the store options to true. The Deferred Migration API has runtime compatibility all the way back to macOS Big Sur and iOS 14. Deferred migration is only available for SQLite store types. Some examples of where deferred migration might be useful include removing attributes or relationships from an entity, changing relationships where an entity hierarchy no longer exists, and changing relationships from being ordered to non-ordered. To finish deferred migration tasks, check the persistent store metadata. If it contains the key NS persistent store deferred lightweight migration option key, that is a signal to you that there is deferred migration work that needs to be finished. The delayed migrations can be processed by invoking NS persistent store coordinator finish deferred lightweight migration. To defer any lightweight migration in your app, set the NS persistent store deferred lightweight migration option key to true in your store options when adding the persistent store to the coordinator. When it's a good time to finish a deferred migration, you can check to see if there is pending deferred work by checking the metadata for the store. If NS persistent store deferred lightweight migration option key is set to true, then call finish deferred lightweight migration. To schedule your deferred migration tasks, consider using the Background Tasks API. BG Processing Task is meant for time-consuming operations such as long data updates and app maintenance. The system will determine the best time to run your task. However, generally processing tasks only run on the device when it's idle and will terminate any background processing task when the user starts using the device. Deferred and stage migration can be combined. If you have a set of complex migrations that may take a while, consider designing stages that take advantage of both APIs' capabilities. Returning to the example model in Model v3, where we remove the attribute flight data, this might make for a good deferred migration candidate. There are 3 great new technologies in Core Data. Encapsulate your custom data types in a nestable, structured way using composite attributes. Perform complex model migrations using staged migration by decomposing your model changes. And turbocharge your app's performance by delaying some migration work using deferred migration. All 3 technologies work in harmony to improve your app. Our team is excited to hear how you use these new technologies. Thanks for watching and have a great WWDC.